Good morning, everybody. This is Dr.R.Menaka, Associate Professor of IT Department. Today, my topic is solving the NQN problem using the backtracking. So, what is backtracking? Backtracking is nothing but the modified process of brute force approaches, where the technique systematically searches for solution to a problem among all available options. It does so by assuming that the solution are represented by vectors from V1 to Vn of values and substituting these vector values while traversing through the domain of the vector until solution is found. So now by this picture, so we start from the root and to the level 1, level 2 like that we try to traverse toward the nodes, and then once the solution is received we see the solution. Okay, we conclude this is a solution, and then again what we do, again we try to backtrack through the previous level, and then again we have to check it whether any possible solution able to reach or not. Suppose it able to reach me, again we have to try the best from the level n minus 1 like that you have to search it, and again there also you will be getting some kind of solution. Keep that solution as another solution. So like that, possibly we can backtrack and find for all the possible level of nodes, we can find out the solution. So um, for one problem, many solution we will receive it, and among the solution, which one is very optimal one, we can receive it. Okay. Now simply the backtracking we can say is a methodological way of trying out various sequence of decision until you find that word. That is, backtracking allows systematically try all available, and also avenue from a certain point after some of them lead to nowhere. So if there is a point dead end, uh, we cannot need not stop it. So again we can search the backtrack and then find out the different solution also. So that's the important story of this backtracking. And next about the backtracking working. So we have to start from this node. So we're traversing with some vector value. We try to substitute and then find out for we have to move toward the next level like that. Many level we can move it. And after some time we may be finding that is whatever path we traveling, this particular path never gives going to give the solution. So that not going to give the solution can be called as a dead end. So from there again what we try to do, we try to backtrack toward down level, and from there again you have to substitute it some vectors and you have to traverse. So until you get the result we have to try it. So while trying nothing we have to do, we have to backtrack to the previous level, there you substitute the vector and then you find out till you get the solution. So lastly here we get the solution. So this is the backtracking concept. So wherever the solution not able to reach it, there we can declare that as a dead end. Again we try to backtrack and again to go toward the previous level. From there again we start the activity, and if we find that as a dead end, again we have to try the best until we get the success. So that is the backtracking work. So very importantly, application of backtracking is finding the optimization and applying to the tactical problems. And constraint satisfaction problem also comes under the backtracking, and electrical engineering for circuit maintenance and then monitoring work, and robotics for optimized arm moving and any task to be moved in the real time mean we can use the backtracking concept, and same thing for the artificial intelligence also, and same this backtracking can be applied also for genetic and bioinformatic algorithm, material engineering, network communication, solving puzzles and path, etc. So next, this backtracking technique can able to solve a problem like NQ problem, sum of subset, Sudoku, puzzles, Bayes generation, and then the Hamilton cycles. Problem description. So in any n square board, number of queues need to be placed considering the three conditions. So first condition is no two queues can be placed in a same row. No two queues can be placed in same column. no two queues can be placed in same diagonal. So from the diagram we can understand this. So if I want to place already one queue is available there, and if you want to place a queue in this particular fourth row mean, what all the things I have to check in mean, when I try to keep the queue here, I cannot place the queue here because when I try to place the queue here, it is like no two queue can be placed in the same diagonal. So that condition never matches. Next again, when I try to keep it here, again the condition will be cannot be considered because same column the two queues are coming. And like that when I try to keep it here, same two queues, no two queues can be placed in the same diagonal. So that condition also will be have to be considered. So when I try to keep it here, so it can be kept because it is under the three condition never coming here, so we can place it here. So that is a important constraint we have to understand while working with the solution. And now we consider the 4Q problem. The 4Q problem, the empty board has been given, chessboard has been given. There our trial is problem is to keep the queue in the each and every rows. So as we have the 4 rows, we have the 4 queues. We have to place the queue according to the conditions and constraint work. First we can start with placing the first queue in the first row. After placing it, our trial is to keep the second queue in the second row. So while keeping it each and every cell for the each and every cell, we have to check it whether the condition is getting matches or not. If it is matches mean we should not keep the queue in there. So suppose I want to keep it here mean I cannot keep it because no two queue can be placed in the same column. So again, if I keep it here, no two queue can be kept in the diagonal. So again, that is also not possible. So what I do, I will try to keep it here. So if I try to keep it here, okay, it can no any condition is not matching. So okay, we can place it here. So like that, our trial have to be forwarded to placing the queue in the next row. So when I try to keep this queue, what I feel the last row in this queue, let us consider whether anything is okay. Here the scenario is what mean first queue has been placed, second queue has been placed, and fourth queue also has been placed. But think the queue in the one queue has been left without placing in the square. So it is a no save question. So what I have to do? So what I feel it is a dead end row. So if it didn't mean what I have to do, we have to backtrack for the upper level. So what I do, I backtrack it, and what I try to do in the backtracking, I feel if the position of the second row is changed with maybe different solution I may be reaching it. So what I try to do, I changing the position. So from this position I'm changing to this position. After changing this position, next again we have to try the best to make the queue to be placed in this row and this queue to be placed in this row. And then after keeping it, third row has been placed and fourth row has been placed. So lastly we get the solution like this. So the time complexity of the algorithm is n factorial. And now a simple problem solving work for the 8K problem. In the 8 into 8 matrices, they given the feasible solution like first in the first row, they're placing it in the sixth position, and the second row they're placing in the fourth position. In the third row they're placing in the seventh position, and in the fourth row it placed in the first position. And now what we have to do is the remaining 5, 6, 7, 8. These are the rows we have to fill with one key. So for that we have to move to the next level. So in the next level what we do, from the fifth level we check with the queue placing. While placing we feeling that is while searching of the solution we find out that in fifth position, that is in fifth row, in third position, and also in another trial in the 8th position also the cube can be placed. So as it is a DFS solution, DFS means left side alone we can try it. First left side you have to try it. So what we do, we consider this particular solution okay. Then again we have to try forward for the 6th row. So we move to the 6th row. In 6th row we find that is only in the 5th position it is possible. So by keeping it, then moving to the next level. Next level what we do, we search the queue to be placed for the 7th row. So while placing the 7th row, again two possibilities they receiving it. One is under 2nd position and the another is the 8th position receiving it. So first DFS left side alone we moving it. So left side 8th position, in the 8th row we trying the best to find out the result in the this 8th position. Okay, so here we got the result. After getting the result, what we do, again we have to backtrack, and again we have to find out whether any solution able to different solution we be able to find out. So we backtrack it. So backtracking again another possibilities of the 7th row. So that has been considered here. From the 7th row we have to move to the 8th row. So 8th row, when I try to check it, nothing is possible. So what I do, again I backtrack it. So backtrack to the previous level like that. So here again we have to backtrack that. So after backtracking, I finding the um, next possibilities of 5th row. So I'm trying it, and again like that we have to move over the each and every node until we get many different solutions. So among the solution which one is best we can consider, and we lastly solve the problems. Okay, thank you.